We have a mental health day.
Do we have a work day?
You can have it. You can have it anytime you want. Just don't come to school. Right?
Doing anything tomorrow?
Like a work day?
Like
Friday work day.
Let's do it.
My heart goes out to you. You got my full sympathy. I don't know what to tell you.
Wow, Jay,
All right.
wow. That's really good. Wow.
Wow them out.
Wow them out.
Well, what else can I say? What else can I say?
Not much. My son's so
No, I've done it upstairs.
What are we doing, Jay Hollow?
We're looking at number 10.
No.
10.
Way to go. Did you ask if you've ever fished with ponds and been tested? Would you think they're?
Yes, I'm back. Can I take it away from Tage?
There's.
Yeah, is that some like?
All right. So if you look at number 10, you will hopefully notice, well, you might not notice this initially, but when you go to answer the question, you might go, wait, they're just asking me what's f of 2. That's kind of weird, right? Well, then you might go back and reread the question if you missed it. They're actually giving you a graph of y equals f prime of x. So this is a graph of the derivative of some function that lives out in the universe. So how will we get f of 2 based on looking at this graph?
The antiderivative.
Antiderivative.
Yeah, exactly. So like, oh, well, I know I can take the antiderivative and it's related to the area, right? So, I mean, big hint when you see a graph and they're talking about, what? What is it? Oh, she's just joking. I can't hear what she said. So.
We're just starting.
Right now.
No,
I'm missing
I'm a
out.
minor.
If you tell your parents, can I have a mental health day? Don't they just say, sure, stay home?
Not.
Don't they just let you like,
No, there are lots of parents who don't do that.
they say no.
Yeah. I mean, my parents say yes because we're all sad.
And I used to miss a lot of school. If I wasn't feeling 100%, I would just stay home.
Well, Jay Hollow, ours feel like that.
Okay. Sorry to flex on you.
Yeah, that was a huge
Good,
flex.
good
That
flex,
was a
right?
huge flex. Lame, not woke.
Not a woke points deleted. Okay,
Depleted,
so
depleted.
what you do is you say, well, firstly, let me start with something easy here. Suppose I wanted to talk about the integral from 0 to 2. So there's some thinky winkies right there. Why would I choose 0 and 2?
That's
Some food for thought.
thingy.
The integral from 0 to 2. The integral from 0 to 2 of f prime of x. Okay. If I integrate f prime, what do I get? Let's pause on that. That's a big idea.
There's a lot.
What's
of
the
things
derivative
going
of
on
f? F prime. So what's the antiderivative of f prime? F. Okay, make sense?
Yes.
So the antiderivative of f prime would be f. So I'd have, okay, this, so the integral of f prime would give me f, and then I would evaluate that from 0 to 2, right?
Yeah.
So maybe a better way of writing it is, so what's going to happen here? What am I going to get? I'm going to plug in the 2.
2 minus 2.
Yeah. There's a big name for this. This is called the, well, it's sort of an indirect way of writing it. It's called the fundamental theorem of calculus. Okay. Ooh, spooky.
So are you solving A here, or are you just doing the jump?
Yeah, we're solving A. Now so yeah, why did I pick 0 and 2? Well, they, capital T, they gave us f of 0. It's right there. They told us that f of 0 is 10. So now I know this equation has 3 things in it. 1, 2, 3, and I know 2 of them. Or I know, well, I'm about to know this one once I look at the graph. So f of 2 is what I'd like to know. F of 0 is 10. And then how do I figure out the value of this? the area bounded by the curve between 0 and 2. Remember, this is the graph of f prime, so the integral of f prime is just this area. So this area here would be between 0 and 2 would be -2. Everyone okay with that?
Mhm.
But isn't it?
Did I make a mistake?
I'm confused, because it says that f of 0 is 10, so isn't that? Wouldn't it be 10 times 2?
No, I don't know what would be multiply. Let's back up. So we agree with this statement, right? And then we agree that f of 0 is 10, so that's just a substitution basically. I know that that's 10. And then I know that anytime I'm integrating a function from 0 to 2, I just find the area bounded by the curve between 0 and 2. So in this case, so if I was asking in a vacuum, what is this integral? If that's the function that's being graphed, then the answer to that would be -2. So that still seems weird. Probably a couple more examples will maybe clarify for you. But so the answer to this question is 8. F of 2 is 8. Okay.
Yes.
Now there's a really good chance you look at that, you go, I don't feel satisfied with like what's going on there conceptually, which would kind of a good sign if you're thinking that way. How about this? What if this was what kind of graph have we looked at where like sometimes they give you, maybe this is more of a, if you've taken physics, sorry, I kind of got mixed up, but if for those of you who've taken physics, how often do you get a graph where they're basically giving the derivative of something? Like they give you the velocity. That's what I'm getting at, I guess. Say they give you the velocity function, right? If they give you the velocity function, what does this little region, he's talking about moving what direction?
So that's like going
negative. That makes sense? Because this is like negative. So again, think of this as a velocity versus time curve. This is talking about negative velocity, meaning you basically be like losing your displacement. That's why if the particle was at position 10, this would refer to going left 2, and thus you'd end up at 8. And then how about this? This is positive area. So this is actually going to push you forward in your displacement. So anyway, back to just pure calculus here. I mean, if you haven't taken physics, you're probably like, well, I don't really get what you're talking about. You will soon, though, because we're going to apply this to position, velocity, accelerations. Okay, let's get the next one. F of 5. Well,
would you still set it up in like the range from 0 to 5?
you have some options here. I mean, you could, I think it's probably what I'll do. I'll just go from 0 to 5 of the derivative. So that integral would be the antiderivative of f prime is f. So f, now you guys just stop me if that does not make sense. I just kind of skipped like that step. Writing the, yes?
Yes.
Mhm.
This is a big idea here. Hopefully it might not click for you yet, but if it doesn't make sense right now, I'm glad to talk to you about it more. But think about it until it makes sense, because that's sort of a big idea of calculus. So anyway, what's the area between 0 and 5? Well, 5 is right here. So what do we have here? We've got 1, 2.5. So this is positive 2.5 area. And this is negative 2 area. So how much total, what's the value of the integral from 0 to 5? 0.5, 1/2. And so f of 0 again is 10. So my answer is 10.5. Which again, if you're going back to thinking about velocity, it's like, well, I started at 10. This little piece represents going backward 2, and then this from 2 to 5 represents going forward 2.5. So your net effect of that is 4.5. George, yes.
Wait, I'm confused with the 0.5.
just adding these up. So
Oh.
the integral from 0 to 5 is just the negative area plus the positive area. Yeah, Cooper?
Have you done, like, instead of 0 to 5, have you done 2 to 5?
Yes, yes. So the way that would have looked, instead, yeah, you could have gone, well, I know what f of 2 is now, so what's to stop me from going integral from 2 to 5 would be f of 5 minus f of 2. Everyone understand that? And then so this integral is just this positive piece. So positive 2.5 is equal to f of 5 minus 8, because f of 2 is 8. And then you get the same answer. You get 10 and a half. Laura, do you still have a question?
No, I was just.
But yeah, everyone gets the 0.5 now? Like where that's coming from?
So question on these, I was confused, what is the, like, f of 5, f of 2 represent? Like,
That would be the-
that value.
That would be the y value of f when x is 2 or 5 or 6.
So it's not the derivative graph, right? It's the y value.
Yeah, so it would be like, suppose you, I mean, it wouldn't be that difficult to, if given this, you could actually graph what f looks like. I mean, I can show you, like, because this line here, this first part is basically y equals x minus 2. And then the second part is just y equals 1, right? So that means the f would actually be 1/2 x squared minus 2x. It would be a parabola in this region, and then it would be linear in this region, right? So the graph might look something. Now, of course, there's a plus c, but that's what the f of 0 tells us. So the f graph might look something like, here's 0, 10, at least the right side of it. It might look like, I mean, this is not the best drawing, but it might be, well, it wouldn't have a pointy, but it would be like,
Yeah. Okay.
you get how in principle, I could draw what f looks like, and what we're finding in these questions is the y values of the function. So another good example here, Aaron, would be like, this might be like the, say it's like the flow rate function for water coming in and out of a tank. And what we're finding would be the volumes in the tank at these different times.
Okay.
So by the way, what's f of 6 going to be? If you apply the same method,
11.5.
11.5. Because you're basically gonna, there's a name for this, sometimes they call it accumulation. As you move along this curve, you're like accumulating y value, I guess. You're accumulating onto the function. So that's gonna accumulate you 1 extra unit when you go to 6. Or just do that, if you're still confused, just do the calculation. You're gonna find 11.5. Is everyone okay with that?
Okay.
Okay, let's just finish 11, 12, and 13, and then should be good for today, right?
Yeah.